Hello, I'm here, Steve Thomas. I'm here to talk about data visualization and machine learning, my experiences. Okay, so the first thing in my experience that you have to ask is, what is the problem we're trying to solve? When we're thinking about data visualization and machine learning, it's key to understand the problem you're trying to solve. And for whom are you trying to solve it? There are multiple personas that you are trying to solve that problem for. Now, I'm going to let you in on a little secret. These personas, these customers, don't care about you. They don't care about your product or service. They don't care about data visualization or machine learning. No, they care about themselves, their dreams, their goals. They will care much more if you help them reach those goals. And to do that, you need to understand the goals and as well as their needs and deepest desires. So, data visualization. Looking at data to understand the past and tell a story. So I worked on this thing called the COVID tracking project. COVID, you may have heard of it. It was a big thing in the news a while ago. So we had a nationwide chart where we used data to create data visualizations so people could understand and facilitate people's understanding of what was going on. But this was at the nation level. You know, I live in New Jersey. My particular persona only cares about things for New Jersey. So we gave them the ability to see things they care about. Remember that, understanding their needs and things? So we gave them state-by-state views of the data. So another thing you can do with data visualization is you can facilitate appropriate comparisons. There was a big question. Well, more tests call more cases. Yes, they do. No, they don't. Well, what if we actually used data and created data visualizations to see if there was a correlation there? Imagine that, looking at facts. Facts, what a concept. Now, we also use data to tell us stories. Human beings learn through stories. It's the way we're wired. And here, The Atlantic used data and visualizations from that data to help people understand about race and ethnicity impacts of COVID and the disparity between the impacts in different races and ethnicities. But what about machine learning? So I'm here to talk about three parts of machine learning: intelligence augmentation, intelligence automation, and artificial stupidity. So for intelligence augmentation, think about Usain Bolt. At his fastest in a 100-meter dash, he could do 27.33 miles per hour. Neil Campbell on a bicycle went 174 miles per hour. So machine learning is like a bicycle for the mind when you're augmenting the intelligence. So here's an example with XR, AR, VR, right? I've got these nice glasses on and I can look around, I can see the stores, see what's going on. Maybe I see somebody that I know, I can get their name because I'm terrible with names. Maybe they tell me about their kids and I can remember when I last saw them, so I can act like I care about them. Remember that whole empathy and caring about people? People don't care what you have to say until they know you care. Right. Then there's intelligence automation. It's not augmenting my intelligence. It's completely doing something for me. In this case, driving a car. So LeBron James can safely sit in the car while texting and watching a video. You know, it's not safe to do that when you're driving. So now, one thing to notice in this picture, self-driving car. They haven't changed the interior of the car. Why? Do I really need the car layout this way? This happens a lot. If you study the history of new technologies, the new technology should change a lot of things, but it takes a while for those other changes to come in place. Think about that. Study your history, kids. All right, artificial stupidity. Here's a PayPal virtual agent, and he says, "Hi, I'm PayPal virtual agent. I'm just still learning, And, the person goes, "Hey, I got scammed." The response? Great! Artificial stupidity. All right, let's give a more serious example. Here is Boston housing data to determine house prices and how much you can get for a loan. Looks like we have a really good correlation here. There's a straight line going up. It's a pretty good linear correlation. Hey, this is a good work. Our artificial intelligence isn't working. But is it? Let's look at the data. Oh, look here. The data contains information about how many black people live in this neighborhood. Oh, and what's the socioeconomic status? Could there be bias here? Of course there can. How do we deal with it? Well, one, we need to be able to measure bias. And there's like some fancy math where you can sort of measure fairness proxies. Negative numbers are bad, so this is like actually bad, right? So what if we just remove the data about black, whether they're black or not, and their socioeconomic status? The fairness improves a little bit, but it's still bad. Why? Because the rest of the data contains proxies for those things. The data is biased. Just because it's data doesn't mean it's unbiased. People collect it. They have biases. Those biases live in the data. So we could remove the more fancy math. You can remove the fairness, but you sort of lose a little bit of accuracy. So you're left with the dilemma. How do I balance fairness and accuracy? It's a tough challenge, and it's the one you have to struggle with. Now, here's another secret, kids. In order to understand fairness and measure it, I need to know their race. I need to know their gender and ethnicity. So, is it worth trading off some privacy for potential more fairness and accuracy, fairness and less bias? When you kids get to the future, let me know how you solve that problem. All right, so great thing to watch, Coded Bias. It's on Netflix, used to be on PBS. Joy Bulamani, hope I pronounced her name right. My apologies, Joy. From the MIT Media Lab, did a study. She was real facial recognition, and she got the facial recognition software from Microsoft, Google, Facebook, Amazon, and lo and behold, none of them could see her face. I mean, literally, there was no face there because she was black. Why? Because the data was mostly white men. So she did this whole thing, and there's a whole bunch of interesting stuff about bias, and watch the documentary, and Weapons of Math Destruction. It's a book. You may have heard of them. Great read. So tips for beginners. Altair, great visualization library for Python because it gives you visualizations in the grammar of graphs. Words matter. I'll leave it there. So Anaconda, Google Colab, Pandas, great tools. Google Colab lets you use GPUs for free. It's a really nice tool. Python for data analysis. Remember I talked about books? You may have heard of them. This is a great book, if you want to go deeper and understand how to analyze data with Python. And for you kids out there, you can also run the book and play with the data in Google Colab. So you're not actually just reading, you're doing. And that's the thing. You don't learn to walk by following rules. You don't sit there and see some little kid going, let me read this book to figure out how to walk. No, they try. They fall down. They get up again. They fall down again. And eventually they figure it out. You learn by doing and falling over and over again. So it is not fail fast. I want you to go out there and fall. And it's not fail fast, it's learn faster. And failure is important. It's why science is so successful. Thank you.